Good evening. Welcome to my channel once again. Last time we determined how to determine the ground state term for a d6 atomic orbital. Today I want us to look at how to determine the ground state term for d7 atomic orbital. To determine the ground state term for a d7 atomic orbital, as usual, the first thing is to determine the angular orbital quantum number, which is L. For d orbital, it is 2. Then the magnetic quantum number, ML. So as usual, it begins from plus L, 0, and negative L. So since we have the L to be 2, we begin from plus 2, plus 1, 0, negative 1, negative 2. Then the spin quantum number. Each electron can spin upwards, which represented by plus half, or can spin downwards, which represented by negative half. Then we determine that we write down the orbital. We know the d orbital is a degenerate orbital, 5 degenerate orbitals. So we write down the 5 orbitals. Then we write down the magnetic quantum number of each orbital. Then we fill the orbitals with electrons by obeying the rules in filling orbitals with electrons. We have 7 electrons, so we fill the orbitals with 7 electrons. So we obey the Hans rule. Since we have degenerate orbitals, we have to begin from here by filling with a single electron. We fill all of them with a single electron in the same spin. Now we have 2 electrons remaining, so we pair up in opposite spin. That is the Hans rule. The next is to determine the total orbital momentum quantum number. So to determine the total orbital angular momentum quantum number, we add up the magnetic quantum number of the orbitals that contain electron. Since the first orbital contains 2 electrons and the magnetic quantum number is 2, we take into account the 2 electrons, so it becomes 4. The next orbital has a magnetic quantum number of plus 1. It contains 2 electrons, so it becomes plus 2. The next one is 0. This is negative 1, contains only 1 electron. This also contains only 1 electron, so negative 2. So we have 6, minus 1, we have 5, then minus 2, we have 3. Then we determine the total spin quantum number. So to determine the total spin quantum number, we add up or we sum the spin quantum number of each electron together, considering the first orbital and the electrons. These electrons, the first electron is spinning upwards, which is plus half. The next electron is spinning downwards, which is negative half. So plus half, negative half, they cancel each other. So we ignore this. So let's ignore this. The second orbital contains 2 electrons. So this is spinning upwards, plus half. This is spinning downwards, negative half. So plus half, negative half, they cancel each other because the sum of plus half and negative half is 0. So we ignore these 2. Now the remaining orbitals contain only a single electron. They are all spinning the same direction. In this direction, it is spinning upwards, which is plus half. So this is plus half. So this is also plus half. is also plus half. So we add the spin quantum number of each electron together. So plus half, plus half, plus half. And we have 3/2. Then we determine the spin multiplicity, which is represented by 2s plus 1, where the s represents the total spin quantum number. So we have it to be 3/2 plus 1. So 2 cancels 2, we have 3 plus 1, 4. From the previous video, we know that if we have the total orbital magnetic quantum number to be 3, the term is an F term. Sorry. And we have the spin multiplicity to be 4. So we have 4 here. So the ground state term for a D7 atomic orbital is 4f. Thank you. Please subscribe, like, and share the video to motivate me to produce more videos like this. Thank you.